Hello and welcome back to Coach Quant. Today we're going to look at a problem on derivatives. Derivative problems are more rare in the quant interview space, but sometimes you can get them in an interview question. It's good to know how to evaluate some of the more tricky derivatives. So in this case, we have a function f, which we can write as x to the x, and we want to find df dx. So the derivative of x to the x with respect to x. This is a bit tricky um, because it's a power and both powers involve the variable that we are differentiating. So it's x to the power of x. And so a way to deal with this is always to use um, the trick where you can raise the entire expression or write the entire expression as e to the power of the natural log of whatever you're writing, right? So one way to write this is to consider the fact that we can write x as e to the natural log of x, right? This is a rule in general. You can always write x as e to the natural log of x. And so if we plug this back into our formula, we can write f of x as e to the natural log of x to the power of x, okay? And of course, this is equal to e to the x times the natural log of x. And so we've rewritten f of x in a much easier way to differentiate, um, because we know that the derivative of e to the something is just equal to the derivative of whatever's in the exponent times the original expression. So the derivative of this is just d dx of x natural log of x times e to the x natural log of x, right? And the derivative of the inside, we just use the multiplication rule. So this is just equal to 1 times the natural log of x, right? Because the derivative of x with respect to x is 1. And then we add x times the derivative of the natural log of x, which is 1 over x. And so we multiply this on the outside, and our solution is 1 plus natural log of x and e to the x natural log of x, which is equal to, remember, we know that e to the x natural log of x is just x to the x. So we can finally rewrite this as 1 plus natural log of x times x to the x. Okay, and we are done. See many more problems like these, completely free and with their full solutions and hints. Go check out coachquant.com. And I've left a link in the description so you can access these free materials in the description. I've left a link to coachquant.com. Please check it out.